my original iPad charger failed a few months back and ended up taking out my old iPad and killed the charger IC inside of it. So I've got a new iPad up there. It's an iPad 4. And I've been using a little Samsung charger. It's a genuine charger, but it's only rated for, I think, 1 amp at 5 volts. When the iPad needs about 5.2 volts, I think 2 amps, to be able to activate the charging circuit fully and charge it as fast, well, faster than the charger that I'm using at the minute. This was, I haven't used this all day, and it was on 20% when I plugged it into charge last night, and it's 54%. It climbed up to 83, and then I've only used it for about 10 minutes today, and it's gone to 54. So I thought that I would start a little project, rather than going out and buying a charger and having the risk of it being another fake Chinese one. I thought that I could start building my own, just as a little project really. But so what I've got here is, well, the heart of this build is this. This is a DC to DC converter. It takes 12 volts at 2 amps, and it converts it to the output of 5.3 volts at 3 amps. So it's 15 watts of output power. And I've actually been able to pull 15 watts from one of these. My uncle uses these, and he's let me have this one, which is why I started doing this project. You can get these on eBay as well, I think. It just has a USB plug there, and these are the 2 wires that you hook up to your power supply. So to supply this DC to DC converter, I have one of these little 12 volt 2 amp power supplies. I got off eBay for like £5 each. In fact, I have another up here, which I use to run my LED lights. Made a few modifications. I put a few heat sinks on it. But these are pretty solid little supplies. They're very nicely built, and the output is pretty clean for something, you know, this cheap. What I've done is I've replaced the output capacitors in this with United Chemicon. The primary cap is it says Nichicon on it, but it's not a Nichicon, it's actually like a Chang or something. It's a fake Nichicon. So at some point I will have to change that primary cap out, because I don't want a fake cap causing an output ripple or anything. But apart from that, these are pretty decent little supplies, and it should be suitable for supplying this. It's an open frame supply, and it has little mounting holes for screwing it onto somewhere, which I'll show you where I'm going to be mounting it in a bit. I've just got this old wire here which I cut up a while ago. I'm just going to shorten it and have this pretty it's not modular, so I can't, you know, say if I was to go on holiday, you know, I can't just unscrew this from where I have it and take it out with me. I will have to have a separate charger, but for, you know, just use in my room, this should be able to charge my iPad a lot better than the one I have at the minute. You'll notice there's a little heatsink here and some thermal adhesive. What I'm going to do is I'm going to peel this sticker off that I put on there originally, and I'm going to put this heatsink on the side just to help it cool. I'm going to take the lid off this power supply because there's one modification I want to do to it, and I want to go over the soldering as well, because when I recapped this, it was pretty much when I just started soldering, so I'm not sure how good the solder quality is going to be. This is just my iPad charger cable. I think it's a Thunderbolt cable or something, I don't know. I'm going to be mounting this on this little table here, and I'm going to be putting the power supply up there. I'll put it quite high up because, and the most important thing is that it's under the table, because I do have drinks on here and I don't want to like spill it, and if any water was to go in here, you know what would happen. So I'm going to be mounting this under the table, and I'm going to have the USB plug about there as well. So have the USB plug about there. It's just for fun really, just to see what I can do. I'm pretty bored and have the parts, so might as well give this a go. I'm going to start taking this power supply apart, and going to take the PCB out, and I'm going to desolder the LED that's on here, because when this is charging at night I don't want to have the LED outputting light into my room, because it'll keep me awake basically. So yeah, let's take the power supply cover off. So here's inside of one of these little eBay chassis PSUs. Pretty decent. I've already actually done a review on one of these, so I'm not going to go into too much depth, but Chemicon output caps, 2200 microfarad 16 volts. Got two of those on the output. I think one is for the oh no, they're both for the plus 12 volts. So yeah, pretty good output filtering on there now. Too bad the primary cap is a fake. But I don't have one of those in stock in that value, and I think it will be okay for a while. So to take this out, there's a little screw behind this sticker that holds this brace on, which basically puts pressure on the switching transistor and the output diode so it can cool on the chassis. That's why I'm going to be putting a heat sink against the back of those two, so they can transfer heat to the metal chassis. Then the heat will go onto the heat sink and it can dissipate it a lot easier than just this chassis here. Yeah, these aren't too awful bad. So I'm going to take the board out. I've got the heatsink on the power supply, just waiting for the glue on it to dry. So what I'm going to do now is I'm going to get this stuck onto the cabinet here. There's a bit of dirt, as you can see, which I'm going to have to clean. It's quite nasty. So I'm going to get the USB port probably about there or so. I'm going to super glue it down, because I don't really care about the cabinet. If it gets, if it gets destroyed, it can go in the bin. So let me get that stuck down now. I'm going to clean it off with IPA, the surface, before I do stick this down, just so it's nice and smooth. Yeah, there's a bit of gunk going off there, but I'll get that stuck down and get back. Here's what I've got so far. Super glued the connector down, and it is rock solid. And super glued the converter down. Just tinned off the ends of the wires. Got a heatsink on the power supply. And I've siliconed that down and just put some super glue around the edge just to be extra sure. So I'm going to let this all dry. When it is, I'm going to hook up the wires and drill a wire at the back. So yeah. So here is the table complete. Got a wire brace on there, and I've just sealed that off just in case of any drinks or anything gets spilt. Nothing's going to get poured in there. There's the power supply, the converter, and the port. So I'm anxious to get this set up. I'm going to see how it goes. Alright, so the project is complete. We have a look into here. Got it plugged in. My iPad plugged into the USB port. There's the converter. There's the power supply. And everything else. So, here's a quick look. And if I can get this in. Very awkward little connector. And it actually charges it. 45%. And the charger symbol is on, whereas with the charger, see if I can find it. The charger I was using before, it didn't even turn on the charging symbol, so it wasn't enough, and I had this stuff laying around, so why buy a new charger when I can make something? Yeah, it's not the most best idea because it's not portable, but I can keep the one that I have for portable when I need a portable iPad charger basically. But yeah, it's been a quick little build guide. When I get an oscilloscope, hopefully soon, I'll check the output on this and just see if the ripple is good. It should be, because these DC to DC converters output fairly stable voltage, and the power supply itself has got pretty stable output voltage, so I don't expect there to be any problems. But if there is, I will post a follow-up video of me taking this entire system out if it has too much ripple on the output and switching back to a normal charger, but I don't think that will be the case with this. Thanks for watching, and see you in the next one.